can only be kind of used if you have a source charge. It's kind of hard to determine the directionality of this force because in repulsion you have them going both different ways, so you have different vectors. But what you can do is you can have a source charge and a point charge. So we can just use the same example right here and make one of them a source charge. So this would be this one. A source charge basically means that it does not move. And a point charge will move. And I'll show you how this is helpful in determining directionality. Oh, and for this problem, you can just leave it as it is. As I told you before, that you can't really have one direction unless you have one that is just staying there. And the problem would have to tell you that. So let's say this is staying here, and we found out the force before, which was 1 times 10 to the 9th newtons. Now what will happen is that since this is staying here, this will be the one that will be repelled. So we only have one directionality here. So what we can do is we can think of this as positive. Like if it was on a coordinate plane, then this will be positive direction. So just leave that as positive right here. And that's how force is a vector in Coulomb's law perspective. Now, another important concept are electric fields. And this is basically just like if you go to a store, or let's say some person right here is wearing some strong perfume. I don't know. This is a perfume. This is the red perfume. And you're standing right here. So this is you. My cartoons are really bad. So you're standing here, just walking into the store, your favorite candy store, and you see this person. So just as you walk into the door, you start smelling their perfume. Right? And you notice that it's really strong just when you're right here. And then you walk even a bit more closer until right here, and you notice it's making you really dizzy because the perfume is so strong. Now let's have another example. And this is you right here. Another store. Your favorite chocolate store. And this is a door. This is a other person. I'm gonna do it in another color. So this person doesn't have that strong of a perfume. Let's say his or hers is really tiny. Yeah, that's a perfume. So it's not that strong. It's really light. And you won't get you have to walk until here to get the same strength or the strength of the smell as right here. So you'd have to walk a bit closer, but that'll be really awkward. So don't do that unless you're just passing by. So that's how you have to imagine the field lines, which are basically like how strong is one charge. Like this will be the source charge is on another charge, the point charge. I see that. I hate like just doing this. And the stronger the source charge, so just like the stronger the perfume, the more this person or this charge, you can think of the point charge, will be attracted or repelled. And same scenario here. But with this one, let's say if this is like plus 10 coulombs, this is like 0.1 coulombs. And so his field lines are not that strong, just like his perfume isn't that strong. But what we have to notice here is that even if you're not here, his perfume will still be strong, because it will be like really concentrated in the air about here. And even if you're still not here, this perfume will be really strong here because it's more concentrated here. So it doesn't matter if, like here in this situation, if you're not here, or in the case with the charges, if the point charge is not here, the source charge will still emit that field or the strength. So it's a really important concept to learn.